Now the next formula we're going to tackle has a little different twist to it from those that we've seen prior to this. And that twist is because the variable that we're solving for, little m, you notice is contained in two different terms in this formula. Now just a caution and a reminder that we need to maintain the case of the variables throughout this process. So the e on the left hand side needs to be kept as a capital E, and all the variables on the right hand side need to be written as small case letters. Now, as we've done with other formulas involving a fraction, my recommendation would be to eliminate the fraction from the equation, which means we need to multiply each term in the equation by 2. So we have then on the left hand side 2 times e equals 2 times 1/2 m v squared plus 2 times m gh. So on the left hand side we then have 2e, and you'll see that the 2 times the 1/2 will produce a 1, and 1 times mv squared is mv squared, then plus 2 mgh. Now here's where the strategy is a little bit different from what we've done before. Because the variable that we're solving for appears in both terms on the right hand side, what we need to do next is to factor that variable out from both terms. So we're left then with, on the right hand side, little m times the quantity v squared plus 2 gh. Now you notice then the coefficient of little m is the quantity v squared plus 2gh. So to finish up then, all we need to do is to divide each side of the equation by that coefficient. So our final result then is little m is equal to 2 times capital E all divided by v squared plus 2 gh. Now just in general, your strategy when you're solving a formula for a variable that appears in more than one term will be to put all of those terms involving that variable on one side and all of the other terms on the other. Factor that variable out from those terms that it's contained in, then divide both sides of the equation by what's left inside the parentheses. Now, I know none of you would think about doing this, but please note in this final answer here that you can't cancel the 2 from the second term of the denominator with the 2 in the numerator because the v squared doesn't have a factor of 2.